Hello again. I think it's 16:02 and I think we can start, right? I'm sure more people will join as time passes by, but it's okay. For me, I don't have much to say, just a warning or a note. I am recording this session and I'm planning to publish it later on. So if you have any objection to that, let me know and I can blur your name or your voice or your face, whatever is visible. We can work it out anyway. So approach me after this event or during this event and I can arrange that. So today we have Kirill with us. He will talk about spec-driven development for LLM coding specifically, which is very interesting and very hot these days. Thank you, Kirill, for being here and for contributing to DevTech, to our community, and for taking that first step with this community. It's really important. I really like when this happens. So I'm not gonna steal more of your time. The stage is yours. You can share. I'll stop sharing. You can share and you can start anytime you want.
Okay, can you see the screen?
Yep. Yep. I can see the screen. I guess everyone can.
Okay, then first of all, George, thanks for the invitation and thanks for opportunity being here. And I share the exactly same idea that the whole topic of LLM extremely hot and extremely popular right now. And interestingly enough, that one of the biggest application today of LLM is to make new software. And this is exactly what I would like to discuss today, what I would like to share with the audience. I would like to share exactly my real experience. Um, this is not like a theory or a book. And I hope that my ideas that I'm going to present today will save you some time and pain. So this is not about how to write prompts. This is how not to turn your project into a mess with AI. So what we are talking about in existing project, I asked LLM to implement a new feature. And I ended up with half of my project rewritten with questionable quality, let's call it like this. What are the typical issues with LLM-assisted coding? I would name a few. Maybe for me personally, the biggest issue is unpredictable big diffs, which are impossible to review. Code generation became cheap thanks to LLM and AI. But with that, review process became extremely expensive. LLM doesn't know your context, doesn't know team agreements, your product vision, and your personal style. And these are the basis for all the trouble we have. But let's start our journey with some demo, how it usually happens. And for the demo, I have existing product. It's my Telegram bot, my pet project. And regarding first, maybe I need to give you some little bit background, what kind of problems this project solves. Maybe as some of you, I have tons of long reads and URLs I would like to read, but usually I never actually read them. And the idea of this project is quite simple. you send a link and you get an audio summary in a couple of minutes, and yeah, you could listen to it while cycling or driving or in U-Bahn, whatever. And important detail here that I'm the author of this small project, meaning that I know how it should behave. I know how it should look like, and like all the nitty-gritty details, I'm aware, like how it's supposed to be in general. And yeah, continue with the product. Most of the times, most of the long reads are boring or the topic is not relevant to me. So short summary is fine for the most of the cases, like 2 or 3 minutes of audio, fine. Now I got the main idea of this text and I can decide like, and usually the decision is, okay, yeah, that's enough. But in some other times, I want to learn more details about this topic, about this long read. And for such cases, longer and more detailed summary is needed. And as of now, the product only has short summaries. And the task, which I will use as a showcase of my idea, the task I want to implement is edit a feature, make longer summaries. And everything you see next, real prompts and their real consequences. So let's start small. And you see on the picture, like it's a very short prompt, just implement a way to get a detailed summaries. That's it. And this is a starting point of a disaster usually. After some minutes, LLM delivers the result. And on the surface, it looks fine. But details look suspicious. And when you start reading, it gets more strange. It's hard to say what exactly is done and why. And there is no way to quickly check this, to understand like what the hell I'm looking at. And I prepared some examples of these weird things on different levels, from the level of the code to the level of the product. So first of all, the code, and you could see some details on the screen. This code definitely smells. Examples on the screen, some values hard-coded in multiple places. As a quick solution, config values or values from the config might be a better choice, but somehow the agent LLM decided to skip this part. So from the code, let's go to the architecture. And architecture is also affected. The product itself is based on LLM, and for LLM, we have to store some prompts. And for that, we already have a file with prompts. You see this YAML, and we have a specific class. It's called prompt builder. And if this div came from a junior developer, you would spend around like 40 minutes just to understand why prompt builder was touched. With LLM, it's even worse. You must probably do this 10 times a day looking at those divs. And what agent did, it added the prompt pieces into the builder. So it's basically hard-coded some pieces of prompts into the class. It is also extended the contract without a clear need. And I would summarize this that I had one source of truth, my prompts YAML file, but now I have two sources of truth. It's not only prompts YAML, but also some parts are now in the code. And long story short here that LLM does not respect your architecture unless you explicitly enforce it. But this is not all. Let's move to the product. On the product level, the messaging app Telegram has an idea of a command, and it is helpful when you use Telegram itself or some bots on top of it. And usually, a command is a short word starting with a special character /. And you could see on the slide, there are already some commands implemented, like len command to change the language, or help command to get some help. And okay, maybe LLM decided to implement this long summary using commands, maybe. But somehow, the agent decided to implement it in a different way. Now, the user must remember some magic word, and this is not even a Telegram command. This is a completely new way to use a product. You see some hashtags, instead of real commands or instead of buttons, which you could also use inside of Telegram. This is a broken user experience. The model chooses the easiest path for itself, but not for the user. Okay, so in total outcome from our first attempt, I wrote one line, one prompt, and the model made dozens of decisions for me across all 3 levels. I don't know if you've been to such situations, but once you do, you will recognize it immediately. You asked for a tiny change, and the model touched way more than it should. Okay, so what could be a solution? How do we fix this? The key is define, once again, define the scope and boundaries. From my observation, most of the real work in engineering is understanding the problem, defining the edge cases, resolving contradictions. It's not just what to build, but also how. Things like what can be changed, what cannot, what matters, what doesn't. And if you don't define this, the model will do it for you. And recently, I read a great article on very similar topic. The idea of the article is simple. When generation is cheap, taste become critical. And what is taste? The taste is seeing patterns that don't fit your case, rejecting weak solutions, explaining why something will fail. This is exactly what we must do when working with LLMs. If you cannot explain why a solution is bad, you cannot capture it. And if you cannot capture it, the model decides for you. And this is exactly where the idea of spec comes in. A spec defines the scope and boundaries, and that's why a spec is a way to preserve your taste. AI is an infinitely fast but very average software developer. And a spec is a way how you could turn it into a software developer who actually understands your project. Now let's compare what are the differences between prompt and spec. Spec can and should be versioned, and prompts cannot. Prompts are not stored in the repo, or at least it's not as easy. But with specs, it's definitely absolutely possible. And my idea is you better store it inside of your repo. Specs can be used for code reviews process, and prompts usually cannot. With the spec LLM, output becomes much more predictable in general. And you can think about it from this perspective. Prompts are just requests to LLM, like HTTP calls. For example, read the spec, ask questions, find contradictions, or implement this specific spec. And from other hand, specs are the actual definition of what to build, how to build, what to change, and what not to change. And specs live in the repo. Now the question is, okay, maybe it sounds interesting to you, but how does it look in practice? Let's talk specifically about this. Let's try to implement exactly same feature with exactly same product. We still want to build the feature for longer summaries. But this time, let's try to do it with a spec. Okay, then the question is, what is a spec from that perspective? What does the spec look like? What is inside of it? And actually, it's pretty straightforward. It's just a text file. From my experience, it's better to have some fixed structure, like three parts: a goal, what we would like to build, constraints, it's about how we would like to build it, and acceptance criteria, what success looks like. And for our example, for our feature, some key parts would be: don't touch the prompt builder, create new prompt in prompts.yaml file instead, or do not introduce hashtags or weird hard-coded markers. Use a context button instead. And you see the spec could be quite long, like 100 lines or 100 plus lines. And by the way, usually I generate those with ChatGPT, and I will cover this process a bit later. So let's see how model performed with the spec. This time the diff is bigger than it was before, but could happen. But now the diff is much more predictable, and the diff is aligned with the spec. And if you think about it, like, specs are much easier to read and fix rather than code. And in this specific case, the spec was around 150 lines of text, and the diff is more than 1,000. And don't know how about you, but for me, just to read text is much easier than to read code. So that's the idea. And using this approach, the result this time is better and more controlled. Okay, then let's go through all details from code to the product and check that how it's doing on those levels. And code is fine, architecture is also fine, and product is exactly what we wanted. So at the first, during the first try, we didn't specify all the details, and I didn't like the outcome. But this time, for example, I specifically stated that, instead of hashtags, I would like to have a button, and look, there is a button. Or I don't want to change the contract between prompt builder and it is more or less the same. Okay, now we have another method, but in general, the contract is the same. So looks much better to me. So yeah.
Can I ask you a question? There is a question actually by Eugene. He's asking if you are speaking or if those can be used as instructions, for example, as GitHub Copilot has in the GitHub repo or Claude has in the .claude repo.
Just give me a moment. Are you speaking of instruction files? Okay. Yeah, I know. I can understand the question. I would say now I'm talking when I talk about spec, it is not exactly like instructions. About instructions, I will speak a bit later when I will talk about my flow. But now I'm talking about like imagine the situation when you have to implement some task from, let's say, Jira, from task tracker, and you have some knowledge in Jira, and you want to make you want to start your work with your agent, cloud, or a codex, doesn't matter. And you have basically two ways. You could just copy paste the task from Jira to chat, or use it as a prompt, or as an alternative for each task, you could create a text file which I call a spec. And at first, you could just try to use it, what is available in Task Tracker, or what I find much more useful in most cases, you could just briefly discuss your task with, for example, with ChatGPT, and ChatGPT will write very good spec for you. It is not like one-to-one like instruction files, but I have also something regarding these instruction files later in my speech.
I'm muted, sorry. Could it be like a plan that you have in Copilot? So for example, you can ask Copilot, want to make a change. And a common pattern that I'm following usually is to ask an expensive model like Opus. Can you create a plan for that feature? And it provides a plan, which is like the specs, how this should look like. I review that, and sometimes I'm also discussing with the model how this can be improved, or I make manual changes. And then I feed that plan to a cheaper model to actually do the implementation. Is this spec approach similar to this? Regardless, I understand that there are more steps to follow, but is this what you're talking similar to that?
Yes, it is. It is similar, but the idea is, the first step is to prepare something much more detailed rather than initial task, let's say. Instead of generate me new feature, first you discuss with, doesn't matter with which model or with whom, and then you could make out of it a plan or a spec. Spec, really, the word spec I don't really like. It has very strong meaning, like something really formal, but actually it could be a spec or a plan or whatever. The idea is this supposed to be first a file. It's not supposed to be a prompt. So you could store it somewhere, you could review it, you could iterate over it, and you could use it as a basis for the review. And when you use a prompt, you don't want to put too much details in the prompt. Better to make prompts like, hey, Claude, or hey, ChatGPT, hey, Codex, go read this specific spec, this file, evaluate it, like, does it have some contradictions, issues, blah, blah, blah. and come back to me and like list all your concerns. That's the idea. And from your perspective, yes, it could be, you could call it a plan.
Okay, got it now. Got it now. So you create this spec file, you feed it to a model to have some discussion, and then of course at some point you will feed it to a model to do the implementation, but this is a follow-up. This we will see it later, I guess.
Absolutely. Yeah, that's the plan.
Yeah,
Understood. And this is
answered my
Markdown,
question.
right? Because, sorry?
I think this also answers my question. So this spec Kirill is speaking about is more of a plan that I create iteratively using the LLM. And it's not a skill, it's not an instruction, which is of a more general approach, but it's on one single task I want to achieve that I'm using as a file. And maybe later I can create a skill out of that or whatever. Yeah. Got it. Thank you.
Yeah, you don't have to do it like extra complicated. If you want, yeah, you could do a skill or whatever. But like my idea, the whole idea of this topic, just don't focus that much on the prompt. Better engineer what you want and how you want to build it, store it somewhere, and from this you go further. Okay, then may I continue?
Yeah, of course, please.
Okay, so yeah, maybe let me then go to my flow. But first, yeah, the difference is, yes, instead of writing just prompts, better to keep not only like think about what and how you want to build. For example, you could make very detailed prompt, but the problem with prompt that you cannot, or it's not very convenient to store it. Better to store this knowledge, what you build and how you want to build it, and store it inside of the repo. And you could not only use it while generating the code, but also what I mentioned before, with those huge diffs, and if your team has a code review process, those specs they are very useful during that process. Because if you spot something bad inside of the spec, most likely you will find it also in the code. And okay, now let me quickly go through the flow, and I hope this will resolve a lot of questions. So in my case, I use ChatGPT and Codex, and usually I start with ChatGPT. As soon as I have something to work on, I just start conversation with ChatGPT. We discuss some edge cases, some potential issues, and then it is job for ChatGPT to generate the first version of the spec. And then as soon as I have some initial version of the spec, I put it in code inside of the repo, and then I ask ChatGPT to make some prompts for Codex. And this I also find very interesting and useful. Usually with ChatGPT, we work in two different modes. Let's say we generate either a plan prompt or implement prompt. So plan prompt is usually like, hey, please go and check the specific spec, find issues, ensure that there is no contradictions, ensure that the spec is aligned with current architecture, and the current documentation is consistent with what we are going to introduce. And those are the specs for Codex for later stage. And as soon as Codex has no issues with what we are about to implement, then another type of prompt is needed. I call it implement prompt, and this is quite straightforward. It's just Codex, please go and implement what's written inside of this specific spec. And yeah, the role of Codex is, as I mentioned, Codex read the spec and repo, and if needed, Codex could update the spec, and sometimes Codex also could update another documents inside of the repo. And after all, of course, Codex is responsible for generating the code. So idea is simple. First, make sure that AI has no objection, or AI criticize the spec, and like all the topics for you is they are clear and you're fine with that. And after, there is no contradiction between what you're about to do and what is already here, then take it and write code. And actually, I find it really cool when Codex says that the spec contradicts the architecture or some other details inside of the repo. I'm happy because I found the problem before writing any code, and this usually saves a lot of hours for review. And yeah, speaking about instructions, you see on this picture, it's a basically screenshot from the repo. The specs here, I call it iteration number, and there are some additional files and instructions. And what I found useful, this file rules, and this is more or less instructions for Codex, which I update time to time, and there are some rules like please don't run any Git commands, or please do that and don't do this. And some additional files, it's a project map or dev notes. Project map, I would say it's a very high detailed version of README. Architecture is there, most of the contracts are there, and like project-wide ideas and conventions are there. And Dev Notes, it's like a journal for project decisions. Let's say sometimes Codex will try to argue with the current spec and will suggest you to implement it in some different way. But thanks to these dev notes, it could see that, yes, this type of decisions we tried before, and we decided not to go that way anymore. And this will provide additional context for Codex, not only what is now like the state of the art, what is now available on inside of the repo, but also some backstory why we decided to go this or that road. And Codex is absolutely fine to read it each and every time, and this is very handy and saves some time for you. So when to use it, when to skip it, everything which I touched and what I talked about here is not coming for free. It requires some additional effort. And yeah, of course, you need to know when to use it, when not. And from my perspective, I would say if you're talking about long-lived systems, teams, projects, or code reviews, this all makes sense. But if you're talking about some quick prototypes, scripts, probably not. So if you learn or hear only one thing from this speech, I would say don't search for the perfect prompt. Instead, design the solution with the spec and put the spec inside of the repo. If you don't define boundaries, the model will define them for you. And you won't like the result, usually.
So when you say putting it in a repo, do you have a suggestion where, or is it some structured way that it would be advised to follow. For example, with a table of contents, a markdown with a table of contents that navigates the LLM what to search and which markdown to load, or?
Good question. I would say this is another aspect of this. And from my experience, you could start really with something simple. Just make a folder, docs, or if you already have docs, just make a new folder, docs/cloud code or codex or whatever, and put everything there. And if you have in mind some specific structure, or if you need any specific structure, you could make a file like rules. And when you generate your prompt, or when I generate my prompt with ChatGPT, usually, not usually, ChatGPT knows that each and every prompt, when we talk about prompt for codex, supposed to start with, first of all, start with rules, point MD, and then go to this specific spec, for example, iteration 28. And in rules, you could store like whatever you want. You could put like the whole structure of knowledge of your documents inside of your repo. The idea is like you specify 2 entry points. You specify first entry point like generic for every session you want. For my case, it's rules. And second, specifies something specific for this specific session, like iteration number 28. And this is like the prompt you use more or less like every time. When you want to first analyze the specific spec, you start, first read the rules, second read the specific prompt, and then please list all of your concerns regarding the specific spec. Or when you want to implement some specific spec, you could start once again the same way. First read the rules, second read the spec, and then implement the spec. And this the whole structure of your folder with documents you could, of course, store here in the same folder, and you could specify in rules what kind of documents are available, what kind of documents your agent has to read each and every time or time to time. Like you could set those expectations and rules in such a file. But in each and every prompt, you better keep asking to your agent to read it first.
So there are 2 different things here. One is those rules, which might be general on how the agent should behave in my repo. And this can very well be the instructions that we were discussing earlier. So the instructions could be the entry point. For example, instructions for Python and instructions for JSON, whatever, JavaScript, whatever you have in your repo, whatever technology that you are using there, you have these instructions. And then the specs for a specific feature or a specific story is a different thing. These are, we get a story out of Jira or wherever that is. We create a spec file, a plan, let's name it, potentially, using an LLM. The LLM will create that plan following already the instructions that we have in the repo or the rules. So the plan will already be aware somehow of the rules that we have there. And then we get that plan or the spec, and we feed it to the agent, to Copilot or whatever we are using. What I didn't understand is that spec then, where do we actually, you said that we should store it and version it and have iterations on it, potentially what we are seeing here on the screen. Where should those be stored then?
maybe this naming is a bit confusing. This iteration number something is actually a spec.
The spec. Okay, so it's spec 26, spec 27, and so forth.
Yes.
Okay, now I understand.
And it's all stored in JIT.
But how does the LLM know then, or anyway, the agent, which one of those to pick each time? And which ones to explode, so we avoid exploding the token pool, you know?
Yes. And this is exactly the first part here. When I'm done with my first version of a spec, after that, I put the first version of a spec inside of the repo. And then I ask ChatGPT, please generate me a prompt for the coding agent for this specific spec. And ChatGPT will return me some prompt, which will specifically mention, first of all, rules MD, and second, the specific name of the spec, or some iteration number.
Okay, so you put the iteration there, you put the iteration in the folder, then you're asking ChatGPT or whatever you are using, please create a prompt to implement iteration 26 or 28. And then the prompt output will be something, use rules MD to learn the rules, blah, 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 and to implement iteration 26. That's the workflow, you mean?
Yes, exactly.
Okay, so the rules are something that it's pre-created, and the dev notes and project maps are information that we have about the project. So it's the knowledge, let's say the domain somehow, or the way that we need to function within that project. Then we grab a story, we create an iteration. That iteration, we can again ask the agent to help us out, create the iteration number 28. And then a third step, after we created the rules and after we created the iteration MD, is to ask again the model, now help me implement iteration 28 by creating a prompt, or even better, I would say that now for Copilot, create a plan. So we'll create a plan that implements iteration 28 based on the rules and other information you have already in the repo, in the markdown you have in the repo.
True.
Okay, now I understand better. There is a hand up, I think. Thank you. Now I think I got it better. There is a hand up by Sambat. I'm sorry if I mispronounced the name.
Yeah, no worries. I'm Vedashri Sampath. Yeah, I think my understanding is that correct, Kirill? Like I see what you're saying is spec file is going to give can help us in telling the system the correctness of whatever the task, like a definition of done, kind of a thing that is expected for the coding agent to use this spec for it to implement. And I see the instructions.md or skills are how the system has to behave and what are the preferences in terms of what repo, what kind of coding styles, or whatever that extra information that it can use for the development. Is that a right understanding?
It is mostly right, but it is a bit more bigger than this. It's not the spec, or in this case, it's iteration MD. It is not only definition of done. It is also the knowledge or the constraints, how it's supposed to look and work and be implemented at the end. Like you, for example, if you want to follow the existing architecture of the software, you have to specifically mention this and provide some key examples, like don't do this, do that during the implementation phase. And of course, definition of done also. Yes.
Acceptance criteria and definition of done together, like however way we generate.
Yes.
Yeah, sounds good. Yeah, thank you.
And a new question by, I'm sorry again if I mispronounce the name.
Eugene, Eugen, whatever you prefer, it's fine for me.
Okay. Okay. Eugen is the German version, Eugene. Okay.
Exactly.
Got it.
Exactly. I would like to also add, I think I like your idea having those specs as separate files, evolving them during the sprint or whatever, during your iteration. However, these rules and maybe the project map, I would see as an instruction file somewhere, because then they will be included automatically, and I don't need to mention them every time in my spec. So maybe it's like a hybrid solution here, but yeah, I get it.
It varies, actually. It varies from, like, depends on what kind of tools you use. In my case, in this project, I use ChatGPT in Codex, and actually, I mentioned that ChatGPT will generate me prompt which will state, please read rules MD first, but that does not mean that I request this each and every time. The way I organize my work with ChatGPT, it happens kind of automatically. ChatGPT knows the context and it knows what kind of structure I have. So but you could do this, like the core is the idea, and how you will implement it is just the second step.
Yeah, we are using Claude. We're using Copilot in the end, and for coding tasks, we are mostly using Anthropic stack for Claude, Sonnet, Opus, whatever. For describing tasks or things like that, ChatGPT is the best one in our experience. And for cross-checking, like if you would like to review something done, we tend to use Gemini. So we are reviewing a model by another model, which delivers sometimes.
You mean you are reviewing what the model wrote, the code that it wrote?
So if you write things, we tend to use ChatGPT because it's really strong for text. For coding, nothing is better than Anthropic right now. Gemini is close to that. But if you would like to review what Anthropic did, we use Gemini just to cross-check on that.
Okay, got it. So I'm using a similar approach a bit. So I'm not storing the iterations or the plans. That could be potentially a good idea if we could also create a table of contents so we can structure or we can guide the LLM towards the correct markdown if there is a need to actually bring it back up. But what I'm doing is for one plan or spec, I'm asking Anthropic, of course, to create the implementation, to do the coding, and a sub-agent, a completely different agent, to do the testing, the unit testing, and then those two then counter act each other. They need to be both correct in some sense. And usually what I do is expensive models to create those iteration MD files, so the plans, because expensive models can navigate my code base better. They have a larger token input. And then once I have a properly formatted plan with very precise instructions, after I'm reviewing it also, I'm reading that spec or that iteration that you have there, and I agree with that implementation, then I can ask a cheaper model. Sometimes GPT-5 comes for completely free with Copilot Premium, but usually I choose Haiku. I don't know, I always think it's slightly better. So for regular plans, nothing super complex, I use Haiku to create the code and Haiku to create the tests. And then those two usually make a quite good outcome.
Yeah, in our company, we also use a very similar style that you said, George. We are using like Opus for creating the plan, do a deep research and get what we need, and we use cheaper models like GPT Mini that they've launched recently, which is pretty cheap, but it is good for from costing perspective, that seemed to have struck a better balance than previously. We were just using it in auto mode and everything was like using a lot of tokens. So yeah.
Auto mode can be expensive. There is 10% cheaper or something. I think there is, but 10% cheaper. It cannot be cheaper than the 0x that GPT-5 Mini offers. So
Exactly.
yeah, for small stuff, GPT, when you have a very good plan or very good spec, that GPT-5 Mini works very well. Usually it needs a human touch. That's not bad, but usually it needs a human touch. So even if the spec is good, GPT-5 Mini tends to make silly mistakes here and there. So yeah, but for now the effort is that we are getting rid of boilerplate code, right? It speeds up things by avoiding to write all the boilerplate code that we had to write back in the days. And additionally, for instructions or for the rules that you have there, I'm using custom instructions with the front matter. So for example, for bicep, there is a front matter that says apply to all the star.bicep files. For TypeScript, apply to all the .ts and .tsx files. So I structure the instructions for the rules in with a front matter to know where with Copilot which ones to pick up. And then the specs, I'm not storing them actually. Maybe I should. But I use Opus and GPT-5 Mini for implementation. There is Kirill. I don't know. Are you finished?
I only have one last slide for the crowd. Just with the link, if anybody wants to connect or check out the bot, feel free. Other
Which
than
bot
this,
is that?
it's a Telegram. If you have Telegram app, you could
Okay.
run it and you could listen how Grok TTS will make a speech for your long reads.
Okay.
Like you have some text and
Yeah, of course.
but that was it.
So, yeah, thank you very much for your time here and for delivering this for the first time in DevTech. I really appreciate that. Hope we can see you again. But from my perspective, there are tools out there right now. I don't know about Codex, to be honest. I'm not using it, so I don't know about that structure that you showed and how it works in Codex. It's a bit different in Copilot and in Cloud Code. With the GitHub folder and the instructions instead of the rules. But there are tools out there that they can make these rules, especially if they are a lot more structured. So for example, a very nice effort that I'm part of it, and we are trying to test it again and again and see how it works and improve it. There is a library that loads and reads domain knowledge. You might have PowerPoints, Word documents, PDFs, I don't know, whatever. And based on that, it creates a structure with a table of contents. So your agent can follow up and find the correct file relatively fast and without spending a lot of tokens. And then you're also giving the ability to your agent to have domain knowledge, to know exactly why something is done. This is very useful, for example, in app modernization. You have a very old app and you need to start restructuring it. And you need to know why, besides actually changing the framework to a newer version to support Linux, for example. So there is a lot of work happening around what exactly you presented, Kirill, and it definitely worth a follow-up because we live in a world that changes so fast, and currently this spec-driven development seems to be the way forward to have less bugs in the code, potentially also less jobs for software engineers. But that's a different discussion, I guess. Yep. Anyone else? Do you have any comments or anything to add?
Actually, I see some long question about spec flow. Seems like, and to be honest, I'm not sure that I got it right. But the topic I talked about, it's not about spec flow. The word spec itself, it is not about hardcore specification model. No, it's just the idea is simple. Store your tasks, store what you implement in somewhere in the repo. This will bring a lot of benefits to you. If you're talking about spec flow, it's just another level.
Yeah. Yeah, and one suggestion for you, Artem, would be what I just mentioned. You need, if you start adding markdown files and content to your repo, then you will blow up your token limit, and then, yeah, of course, it will not work as expected. Agents or LLMs usually understand very well the beginning and the end of the prompt. And then the middle one, it's kind of a middle ground. It's fuzzy how much they pay attention to it. So you need to guide your agents to read the correct markdown and not everything. You cannot expect to deliver a book and read all that book and then deliver based on that book. You need to somehow create this table of content structure. Maybe I can find that tool I was talking about and share it with you. Give me a second. I will see if I can find it. Where is my friend Z? He is here. And this is the... So I can also share my screen really quick. This little tool here, STD, spec-driven development, and it's doing exactly that. It's optimized for Cloud Code, but it works for other tools too. It analyzes the product, understands the source code, analyzes the domain knowledge by the additional documents you might deliver, the ones that you already have, potentially Artem. It plans all those into features, goals, dependencies, risks, all that structure that is necessary to modernize an app or to just write code. And then it creates these docs that can guide your LLM towards what it needs to do. And it gives your agent a structure on which documents to pull and not everything. And that minimizes that noise that you are experiencing in, and you find problems with implementation. Maybe you can try it out, and yeah, ping me if you have any questions or if you need some help with that or if you have any feedback. But it will add those skills in your repo, and based on those skills, it can very well do exactly what you are after. We've been using that, and it's good. It's good, especially if you have the domain knowledge to create that structure, or if you have the code, an existing code. It's a brownfield project and not a greenfield project. It's very good. It can help you very much. And share that here too. Anything else from anyone? If not, then I think we can leave it here. Thank you very much.
It's a very interesting session. Thank you so much for sharing this.
Yeah,
I think it is very, very useful.
I think it deserves a follow-up, to be honest. It's something heads-on we can definitely do. It's too big of a topic to finish it in one session, of course. So, yeah, Kirill, thank you very much for this. It was very interesting.
Yeah,
I appreciate your time, guys. George, thank you for your effort also. Yeah, looking forward. Maybe a bit later, there will be a follow-up.
Yeah, definitely we can have that. We can do that. Thank you very much for your time, everyone. See you around. See you during the next talk. Ciao.
Bye-bye.
Bye.
Bye.
Christoph, is your hand up or?
No, sorry, it was by mistake. I want to react. I want to clap hands, and I pressed the
Okay.
wrong button.
It's okay. It's okay. We can have it as a ciao.
Yeah. Okay, thanks a lot. Yeah, bye bye. Have a nice
Ciao.
evening.
You too. Ciao. Bye.